All right, CNT140, we're working on Chapter 2. We're working through our terminology. So we're now on to horizontal cabling. That's the connection from the closet to the work area. Horizontal cabling, as we remember, maximum allowable distance for horizontal cable is 100 meters. So this permanent link between the closet and the workstation, closet and the work area outlet, is typically 90 meters max, and that gives us that 10 meters for patch cables in each end. It is typically unshielded twisted pair, this type of cabling here. And again, we're looking at this part of our structure from the closet, from the patch panel, out to the outlet on the wall. From the closet patch panel out to the outlet on the wall. Here's a different picture I'm showing you from the closet, up the wall, above the ceiling, through trays, down the hallway, into a room, and into the outlet on the wall. That type of structure is what we're looking at. In my other plan, or the other drawing I had for you, this part of the structure here, this permanent link from the patch panel down the hall to the outlet, that's the horizontal cabling. It's going to look like this as you look above the ceiling, the cable trays, bundles of your unshielded twisted pair cabling going down the hallway, 90 meters max. It's going to get terminated in the patch panel in the closet, and then as it travels down the hall, again above the ceiling, through, and supported by cable trays like we showed you, down the hallway into a room. Here's the trays in the hallway supporting the cabling. Here's your patch panel, your termination, up the rack and through these trays and down the hallway, down the trays, down the hallway, down the hallway in trays like this, supported, and then it's going to get terminated into down the wall and into an outlet in an office, down the wall and into an outlet in an office kind of thing. That's what's going to get done. Your horizontal cabling, again, unshielded twisted pair, is typically going to be solid core conductor. The solid core conductor has better transmission characteristics, if you will. It has less resistance, so it's able to carry a signal with less loss a greater distance. But the downside of this solid core is if you bend it a whole lot, it's going to break. If you bend it back and forth, and think about bending a paper clip back and forth a whole bunch. You bend a paper clip back and forth a bunch of times, it breaks. The same thing will happen here. So this solid core is going to get used here as this permanent link because you're typically going to install it. Once it's installed, it's going to stay there, Velcro tied in place for the next 10-15 years, if you will, without moving it. So that'll be fine. And it allows you to have a good transmission with very little signal loss. So your horizontal cabling is typically going to be that solid core, unlike the patch cable we looked at earlier, that was the stranded core, all those tiny little cables making up the one bigger cable. Backbone cabling. Backbone cabling is typically going to connect your closets together, as I like to say, switch to switch. It's typically going to be a fiber optic link. It's typically going to be between closets. It's typically going to connect your switches together. If I'm looking at a campus environment, it's probably the links connecting your buildings. If I think about connecting Hall Tech over to Blocker and Blocker over to the Student Center and, the Student Center to the bookstore, those kind of connections are typically going to be a fiber link, a backbone link. So when I'm talking backbone cabling, I'm talking about the cabling going from closet to closet, closet to closet, or switch to switch, switch to switch type of thing. That is typically your backbone cabling. Here it's this link between the closets, this link between the closets, this link between your switches. And it's typically going to be a fiber link for bandwidth and distance, bandwidth and distance. If I were looking at a closet, there is fiber links plugged into a switchboard. That is actually a fiber link plugged into a switchboard. There are fiber links being bundled and routed up into the equipment racks. Here are some fiber links going in between floors. That's actually a hole drilled through the floor and a conduit going down through, and fiber links going down through with the red clay as fire stop, which keeps fire from one room traveling through to the other room. That's a fire retardant clay in there called fire stop. So that's typically your backbone cabling. When they say a permanent link, this is essentially that horizontal cabling link that's installed and left alone. It's this part of your structure from the patch panel out to the outlet. That's typically your permanent link right there. Because again, once you install it, it kind of stays there. It's not going anywhere for probably 10, 15, maybe even 20 years, depending on your facility. Meanwhile, the channel, when they say a channel, this now includes the patch cables on each end. Okay, so the channel is, it has the 90 meters here for the horizontal cabling, but also includes this patch cable and also includes this patch cable. That is your channel. That is your channel. This comes into play when we start certifying cabling later. We can actually run a certification that does the permanent link, or we can run a certification that does the channel. And the channel is going to include the patch cables on each end. They mentioned J-hooks. J-hooks get used to support small bundles of cabling. If I look back, let me look up here. The horizontal cabling coming down the hallway is a large bundle being supported into a tray. Once 2 or 3 pieces peel off and go into a room, a couple pieces peel off and go to the room, they're typically going to be supported by just a J-hook. And that could get anchored to, they have a bunch of different options to anchor into grid work, clamp onto grid work, clamp onto wire cabling that's supporting a ceiling, anchor into a wall, anchor into a concrete ceiling. There's a bunch of different options to do this. So that's used to support a small bundle of cables, 10 or 20 versus 100 or 200. A fish tape might get used to try to get a cable through a wall or through a spot in a building, maybe through a ductwork or a hole in the wall or something like that. That is a fish tape. It's basically a pretty stiff but flexible wire that you can tie your cable to and fish it down through the wall or through a hole or up over a wall kind of thing in a building. That's your fish tape. All right, they now move on to the cables of our cabling. The first one they have listed here is unshielded twisted pair, which we talked a little bit about in Chapter 1. We'll revisit it here. Our first data cabling was our phone cabling. This flat, non-paired cabling that could handle a couple K, if you will, of bandwidth. Well, as they wanted to start putting more bandwidth through, the structure of the cabling needed to adjust to handle these higher frequencies of signals. So what they started doing is pairing the cable and twisting together. The twisting together does the cancellation, and it acts like what they call self-shielding. It's trying to cancel the signal that might be coming from outside to affect this, or this signal here affecting the one next to it. When they did that, they were able to start getting more bandwidth through. Again, phone cabling here, you can get a handful of K, maybe 56K kind of thing. Once we wanted to start getting into 10 meg, they needed to start using cabling that was purposely twisted for the cancellation purpose, and that's where Category 3 comes along. And that was capable of 10 meg. Well, as they wanted to run more signal through, more bandwidth through, or get more bandwidth out of, run more signal through a cable or get more bandwidth out of, the structure of the cabling needed to change to accommodate that. So what they did was they started twisting these wires more significantly, more purposely, if you will, to be able to support a higher frequency signal going through, which would give you more bandwidth. Category 5E actually overshot that mark enough by twist pitch being really dialed in, as well as the quality of the copper used in the cable, that it actually got its own little designator, 5 enhanced. So 5 and 5E, 5 was essentially capable of 100 meg. 5E then starts getting into the capability of gigabit, into gigabit capabilities. Again, as they want to start putting more bandwidth through, the structure of cabling needs to change, so they put a divider down the middle to keep these wire pairs separated, to keep the interference from the pairs from affecting each other. They're able to put more signal through, so get more bandwidth out with that structure, and now we're into the gig and touching into the 10 gig range with this Category 6. Category 6A, they start putting shielding around the outside. Again, I'm able to put more signal through, so get more bandwidth out, but this structure was needed to be able to do that. And now we're firmly into the 10 gig capability with your 6A, Okay, so the categories of cabling, when you say it's a category blah, it designates what it's capable of. Okay, if somebody has a 5E, or let's say they have a category 3 infrastructure in, and they want to try to run gigabit across, it's not going to work. That cable is not capable of that bandwidth. You would need to pull out the old cabling and put in newer cabling that is capable of supporting that signal, that bandwidth. Hence, the categories of cabling are there to mark what it is capable of. We mentioned this before, shielded twisted pair. This comes out of the days of IBM Token Ring. You literally shielded each wire pair. Okay. Screen twisted pair is the kind of thing we just saw back there with your category 6. Literally a full shield, a foil shield around all wire pairs, and that's when you say your category 6A, it tends to be a screened twisted pair. That's what they typically call that. Here is another one of the charts that they have showing the cable categories and what they're capable of, and showing you what's being developed coming down the road. They're working on standards for and connections of and terminations of and so forth. So as the category goes up, the structure is changing to support higher signal and higher bandwidth. Coax we mentioned a little bit in Chapter 1. Coax because the first networks were using coax, and we still do have some connections in homes that are using coax for data. So we at least want to be familiar. Here's your coax structure: central conductor for carrying the signal, foil shielding around the outside. Again, early days of networks, RG8 was used for your thicknet 10-base-5 Ethernet, and your RG58 was your thinner coax, thinnet, used for your 10-base-2 Ethernet cabling. We throw Bob Metcalf in here to remind you he was kind of the brainchild behind getting Ethernet rolling. And here was his concept sketch of everybody tapping into this central coax bus that we move data across. Here is a close-up of the RG58, the first coax, the thick coax that was used, and the transceiver that would bolt around it to tap into the network. And here is the transceiver up close, and the cable that would go from that into your computer. This is basically the patch cable that would go from this transceiver into your computer. There's your RG8, and this is the type of network structure you would have, your bus topology. As technology progressed, they started using RG58, thinner coax, with these T connectors. These T connectors that would twist lock onto the back of a NIC. Here's that T connector twist locked on the back of the NIC, and then you would use another cable to go from here to the next computer. The end of the line would get these terminators installed, so it absorbed the signal and not bounce back into the network. And again, this is your bus topology. There's the terminator on the end of the line, grabbing hold of that signal and getting rid of it, deadening it so it would not bounce back into the network. The kind of cabling you might see in your house would either be an RG59 or RG6. Most likely RG6, that's the more common used for coax in your house. And the type of connection you would have would probably be this F-type connector on the end of that coax. This BNC connector was the type used back in the thinnet coax days, for your thinnet Ethernet, 10-base-2 Ethernet. Alrighty, when we come back, we'll continue our talk on cabling.